بسم الله الرحمن الرحيم. اليوم موضوعنا في مادة الأورال سيرجري هو تكملة لما بدأناه بالمحاضرة السابقة حول sterilization, disinfection and antiseptic. كان المحاضرة السابقة إنه classification of this sterilization to two categories: physical agent and chemical agent. The physical agent that include heat, radiation, and filtration. This figure shows the methods of sterilization are physical, chemical, and physiochemical, and classified the physical to sunlight, heat, vibration, radiation, and filtration. And we have chemical disinfectant like liquid or gases. The liquid that include alcohol, aldehyde, phenols, halogen, heavy metals, surface active agent, and dyes. And the gases formaldehyde, ethylene oxide, and the plasma. The chemical method of disinfection. These chemicals that can sterilize are called chemic or sterilizant. These chemicals that can be safely applied over the skin and mucous membrane are called antiseptics. An ideal antiseptic or disinfectant should have following properties. First, should have a wide spectrum of activity that have many of microorganisms that can kill or stop activity by this antiseptic or disinfectant. Second, should be able to destroy microbes within a practical period of time. Third, should be active in presence of organic matter, like the saliva or blood or other structures. Fourth, should make effective contact and be potable. Should be active in any pH. Should be stable. Should have long shelf life. Should be speedy. Should have high penetrating power. Should be no toxic, no allergic, no irritative, or no corrosive. Should not have bad odor. Should not leave non-volatile residue or stain. Efficiency should not be lost and residual dilution. And finally, should not be expensive and must be available easily. The classification of disinfection. We have first classification depend on the consistency. We have either liquid or gases. The liquid example for alcohol, phenol, and the gases example formaldehyde, vapor, ethylene oxide. Other classification based on spectrum of activity. We have three high level, intermediate level, and low level spectrum of activity. Other classification depend on the mechanism of action. First, action on membrane, like alcohol and detergent. Other, denaturation of cellular protein, like alcohol and phenol. Oxidation of essential sulfide group of enzyme, like hydroxy peroxide and halogen. Alkylation of amino carboxyl and hydroxyl group like ethylene oxide and formaldehyde, and finally damage to nucleic acid like ethylene oxide and formaldehyde. This is classifications that done for the disinfectant drug. We start the first disinfectant and most popular alcohol. The mode of action: alcohol dehydrates cell, disrupt membrane, and cause coagulation of protein. Example of alcohol: ethyl alcohol, isopropyl alcohol, and methyl alcohol. Application: 70% aqueous solution is more effective at killing microbes than absolute alcohol. 30% of ethyl alcohol spirit is used as antiseptic on skin. Isopropyl alcohol is referred to ethanol. It can also be used to disinfect surface. It is used to disinfect clinical thermometers. Methyl alcohol kills fungal spores, hence is useful in disinfectant inoculation hots. The disadvantage of alcohol: skin irritation, volatile, evaporate rapidly, and inflammable. Other disinfectant is called aldehydes. Mode of action of aldehyde: act through alkylation of amino carboxyl or hydroxyl group. and properly damage nucleic acid. It kills all microorganisms, including spores. Examples: formaldehyde, glutaraldehyde. Application: 40% formaldehyde formalin is used for surface disinfectant and fungicide of room and chambers. Operating theaters, biological safety cabinet, worst sick room, and etc. Fumigation is achieved by boiling formalin, heating para-formaldehyde, or treating formalin with potassium permanganate. It also sterilizes bedding, furniture, and books. 10% of formalin with 0.5% tetraparate sterilize clean metal instruments. 2% glutaraldehyde is used to sterilize thermometers, cystoscope, bronchoscope, centrifuge, anesthetic equipment, and etc. An exposure of at least 3 hours at alkaline pH is required for action by glutaraldehyde 2%. 2% formaldehyde at 40 degrees centigrade for 20 minutes is used to disinfect all, and 0.25% at 60 degrees centigrade for 6 hours to disinfect animal hair and bristles. The disadvantage of aldehyde vapor and irritating must be neutralized by ammonia. Has a poor penetration, leaves non-volatile residue, activity is reduced in the presence of protein. Glutaraldehyde require alkaline pH, and only those articles that are waterable can be sterilized. The phenol. The mode of action of phenol acts by disruption of membranes, precipitation of protein, and inactivation of enzyme. Example: 5% phenol, 1 to 5% cresol, and 5% lysol, saponified cresol. Hexachlorophene and chlorhexidine and chloroxylene as a dettol. The disadvantage is toxic, corrosive, and skin irritant. Chlorhexidine is inactivated by anionic soap. Chloroxylene is inactivated by hard water. Application: Joseph Lister used to prevent infection of surgical wounds. Phenol are called tar derivatives. They act as disinfectant at high concentration and as antiseptic at low concentration. They are bactericidal, fungicidal, mycobactericidal, but are inactive against spores and most viruses. They are not readily inactivated by organic matter. The corrosive phenols are used for disinfecting of wallflowers in discarding jars in laboratories and disinfection of bed pans. Chlorhexidine can be used as a propanol solution for skin disinfection or as an aqueous solution for wound irrigation. It is often used as antiseptic hand wash. 20% chlorhexidine gluconate solution is used for preoperative hand and skin preparation and for general skin disinfection. Chlorhexidine gluconate is also mixed with quaternary amino compounds such as cetramide to get a stronger and broader antimicrobial effect, like Savlon, are more effective against chlorhexidine, are less irritant and can be used for topical purpose and are more effective against gram-positive bacteria than gram-negative bacteria. Hexachlorophene is chlorinated diphenyl and is much less irritant. It has marked effective over gram-positive bacteria, but poor effective over gram-negative bacteria, mycobacteria, fungi, and viruses. Triclosan is an organic phenyl ether with good activity against gram-positive bacteria and effective to some extent against many gram-negative bacteria, including Pseudomonas. Is also fair activity on fungi and viruses. Other disinfectant is halogens. The mode of action: they are oxidizing agent and cause damaged by oxidation of essential formaldehyde group of the enzyme. Chlorine reacts with water to form hypochlorous acid, which is microcidal. Example: chlorine compound, chlorine bleach hypochlorites, and iodine compound, tincture iodine, and iodophosphorus. Disadvantage: they are rapidly inactivated in the presence of organic matter. Iodine is corrosive and staining bleach solution is corrosive and will corrode the stainless steel surface. Application: the tincture of iodine, 2% iodine in 70% alcohol, is an antiseptic. Iodine can be combined with the natural carrier polymers such as polyvinylpyridine to prepare iodophores such as povidone iodine. Iodophores permit slow release and reduce the irritation of antiseptic. For hand washing, iodophores are diluted in 50% alcohol. 10% povidone iodine is used and diluted in peri and post-operative skin disinfection. Chlorine gas is used to bleach water. Household bleach can be used to disinfect floors. Household bleach used in stock dilution of 1/10. In higher concentration, chlorine is used to disinfect swimming pools. 0.5% sodium hypochlorite is used in serology and virology. Used as dilution of 1/10 in decontamination of spilling of infectious material. Mercuric chloride is used as a disinfectant. Other hydrogen peroxide. Mode of action: it acts on microorganisms that is a release of nascent oxygen. Hydrogen peroxide produces hydroxyl-free radicals that damage protein and DNA. Application is used at 6% concentration to decontaminate the instrument equipment such as ventilators. 3% hydrogen peroxide solution is used for the skin disinfection and deodorizing wound and ulcer. Strong solutions are sporicidal. Disadvantage: decomposes in light broken down by catalysts, protein cases, organic matter drastically reduce its activity. Other method is physicochemical method. The physicochemical method is mode of action. A physicochemical method adopted with physical and chemical method. Used for steam formaldehyde is physicochemical method of sterilization, which take into account action of steam as well as that of formaldehyde. The saturated steam at a pressure of 263 mm has a temperature of 70 degrees centigrade. The air is removed from the autoclave chamber and saturated steam at sub-atmospheric pressure is flushed in. Formaldehyde is then injected with steam in series of pulses, each of 5 to 10 minutes. The articles are held at this holding temperature for 1 hour. Formaldehyde is then flushed by inflow of steam. The disadvantage of this method: the condensation of formaldehyde occurs and indication of large volume of formaldehyde wets the steam, resulting in loss of latent heat. The sterilization control using a paper strip containing 106 spore of G-citrotrophene. Thank you for your listening this small lecture.